Okay, good morning, at least morning on the Eastern time where I'm located. I would like to welcome you to the webinar. On the initial slide here, you will see a couple of things. Number one, my email, and my name is Tom, as you can see. I do offer that if you have questions beyond the webinar, by all means, send me emails. I do answer them. Also, like I said a few minutes earlier, there's the link to our website where you can actually grab the PDF. Just once you get into the webinars, find today's webinar, and there should be a link where you can download the PDF file that's associated with this webinar. If you have questions, please use the question box as opposed to the chat. And let's get going. So, very brief about myself. I'm one of the founders of our company. My CICS exposure goes back to CICS OS Standard 1.0, 1969. So I've been working with CICS for many, many, many years. Still a mystery to me at times. Still a lot of fun, a lot of new things. I keep up with technology. I am the CTO of our company, so that is part of my mission. So let's get going. A lot of turf to cover, as it says, kind of for all. Bit technical, bit applications, you'll see as we go through. Okay, so let's look at the application first. So in MQ, I have many commands. Unlike standard CICS commands that are done through must be translated through a precompiler, in MQ's case, we're going to do actual calls. You'll see. So we have a bunch of structures, and I'm not going to get into any great detail here, but there are 5 structures that basically every MQ application uses. The OD is the open or object descriptor. It's for opens, you'll see. The MD is working with messages. The GMO is for get message options. The PMO is put message options. And the big guy, the MQ structure, I notice I put suppress on that thing. That's about 22 pages worth of COBOL copybook. Most experienced MQ programmers do not need to see all that stuff in their compile list. Also, a bunch of variables are required. The HCON is a connection handle. The HOBJI, HOBJO are object handles for input-output queues. Okay. Options, you'll see we set options when we do certain things. I have to work with both the message in, message out lengths in my application. Get it wrong, some bad things can happen to you. Data length is actually CICS, or I should say MQ, telling me how big the actual message is. As with any command in CICS, the MQ calls require or provide a feedback through what's called a completion code, or the comp code as you see, and a reason code. Comp code is basically okay, it worked, warning, it kind of worked, and failed, it didn't work at all. And of course the reason will give us a reason why that is true. So those are things that must go into every MQ application. So moving on, I need to define message input, message output areas in working storage, in this case. So again, my messages in my little test application were fairly simple. As you can see, there's not many fields defined in each of those. However, I got a little comment for you there. If the actual message area exceeds 200 to 300K, kind of my rule of thumb, if you will, then they should be in the linkage section and their storage acquired through a CICS get main. Principal reason for that is every working storage, COBOL working storage, and again, dynamic storage area, PL1, and execute interface storage and assembler, the so-called working storage areas are always copied for each task, each user. So if I had a 1 megabyte message in MQ defined in my working storage, that would get copied for every user that's using the program. Boy, I could run out of CSS storage in a real big hurry. So that's kind of my rule of thumb. 200 to 300K, you probably want to put it in linkage section and do get mains, especially as you want to build message outs. Mine are fairly simple, so I don't have to do that kind of stuff. Okay. Again, your mileage may vary. All right, so let's take a look on the next slide. We'll take a look at our procedure division. Just so happens, okay, that I'm showing you probably one of the more complex calls, put one, MQ put one call. It is actually a combination of an MQ open, MQ put, MQ close in a single call. But in most CICS transactions, right, we're very short-lived. We tend to get some stuff, technical term called stuff, from a user, right, or an application, update files or databases, and provide a response. Typically, one message in, one message out. So if that's true, I save myself a bit of coding, if you will, by coding a single call, okay? If you will, put one call, okay? There is no corresponding get one, you'll see, but hey, Now, it does save an interaction, actually two interactions between your application and the actual queue manager itself. So you do save a bit of overhead. However, that quickly disappears when you have more than one put one call, because it's got to do all three calls, right? Not going to cover line by line by line, but basically the first few moves are setting up the message. The next several moves are to set up various parameters. And notice we're setting up the MQOD, the object descriptor, because it is going to do an open. We're setting the MQMD because we have to tell it the type of messages and things. And of course, then we do the call, setting the options. In this case, we're not doing any sync point processing, so the messages are not under unit of work. Okay, say that because the no sync point means that if my task appends in CICS, messages will not be rolled back. Your choice. And again, the put one call, you can notice it's a call. It is a static call. I make a comment at the bottom of the text, right? At the very end of this section, I will show you how to do dynamic calls. Static calls require a hard link with a stub module, okay? Because the actual program names in the MQ interface are not MQ put one. You'll see what they are later. So put one call, not bad if I'm working with a single message. Okay, over to the next slide. Here we have an MQ open. So if I don't do a put one, if I must do my open, here's a call to do the actual open. Now, again, I set up some options. Notice I'm defining the queue here as input. I must define the queue either as input or output when I do the open, okay? And again, within a CSS task, I can have many queues involved, okay? One thing I don't do, and you will not see it, an MQ con call to connect to a queue manager. That interface or that connection has already been established by CICS itself. You'll see the definition in a later section that I make to tell it which queue manager. As it is right now, the application is not allowed to issue an MQ con call to connect to a given queue manager. A couple reasons for that. One is the overhead. Two is they just designed the interface similar to DB2. Could say stole it from DB2. And by the way, I had done an earlier seminar on the CSS DB2 interface, so you'll see a lot of similarities between the two, because there are. Anyways, so we supply the object name here, which is the actual queue to be opened. Again, this is a static open call. At the end of the section, I'll show you the dynamic. And of course, after the call, I must test completion code and eventually the reason code. We'll see a little bit more about the open call a little bit later. However, every open will require a unique object handle, in this case, HOBJI. Not very strong naming convention, but I could have many queues. The default, by the way, if I don't change it in MQ, is 256. You are allowed to have 256 unique HOBJ handles associated with your application at any given point in time. I think that's sufficient. Moving on. So if I'm doing an input queue, if I'm opening a queue for input, I must get messages. So on this slide, we see the MQ get call being done. This actually is an MQ get with wait. Notice I am setting something called wait interval, MQ GMO wait interval, and I set the options to MQ GMO wait. Again, no sync point, MQ GMO no sync point. So messages retrieved not under sync point control are automatically deleted. MQ standard is if you get a message with no sync point, it is automatically removed. If you do it under sync point control, it can be rolled back as if it was never processed. So a little caveat. Again, I just did this for illustration purposes. But we are going to do a wait. Why am I going to do a wait? Because maybe this has sent off a request to another application and it's waiting on a response coming back. Well, the wait here will wait a little bit of time. In this case, 20,000 milliseconds. So that is 20 seconds. This application is going to be suspended in CICS, waiting for a response from somewhere. So again, the put one might have put a request message, and I'm kind of setting the stage because that's what my little application has done. Puts one to do a request message and waits on the reply coming back. Don't pay too much attention about my little test for the message ID being none. That's kind of a way that I tell myself I've had input or not, okay? If there are no messages, I'm going to get an error, okay? But I also got a little bit of different logic I do, so, okay? At some point in time, your application will do an MQ close. Now, close is done on a queue by queue basis, so hence the HOBJI here. Not a real requirement for you to close queues. However, it's just a very good habit to get into. Not much goes on at a closed queue time. Perfectly fine. That you do it or don't do it, but I would. Okay. Okay. So that's pretty much the calls. I mean, there's some more things, but I wanted to, like I said earlier, show you dynamic calls. Now, I prefer to use dynamic calls myself. A little bit of extra coding on my part. I have to include in working storage these various picture X8s that you see here. Those are the actual module names. Notice they all begin with CSQC. So CSQ is the beginning of everything in MQ on ZOS on the mainframe. The C means CICS modules. If it was CSQB, as in Baker, it would be batch programs. That is why I can actually code an MQ module that can actually work both in CICS and in batch. There are easy ways to tell where I'm running, if I'm a batch program or a CICS-based program, and I can vary the module names I'm calling based upon where I run. So I can have a kind of an MQ common piece of code that works between the two. Here you see all the typical application calls. Again, we don't do the MQ con or conx. Likewise, we don't do the MQ disk to disconnect from there. The difference, notice the little call on the bottom for the put one, call MQ put one, using same parameters as the put one earlier. So again, it's no hard links, if you will, they're actually done. you cannot really compile COBOL programs with the dynam option, right? Because of the way that the CSS commands or SQL commands are translated. Here, right, again, the module names are not the same as what you would call in a static calls. So I code dynamic calls. One last little thing I kind of associate with the application program. Very big issue in CICS, if you will, or in any batch, any application. Now it says application must always set MQMI none or do MQPMO new message ID on the put, MQPut command, or put one. That is so that MQ generates a unique message ID. If I don't do that, you can see what happens. Message 1, 2, 3 go into the queue with the same message ID. Now, message IDs are 24 bytes, as it says on the bottom of the screen there. The first 4 bytes is a constant, CSQ blank or AMQ blank for distributed. First 12 bytes of the queue manager name. Well, on ZOS, the queue manager names are only 4 characters. That is because it is a ZOS subsystem. However, the queue manager names on Linux, Unix, Windows could be 48 characters. So IBM picks up the first 12, sticks it in there. Last 8 bytes is a binary field that's extracted from the clock. So every tick of the clock, it becomes unique. And that's the whole idea. MQ uses it to identify messages uniquely. You can actually retrieve by a unique message ID if you know it, and it can be saved. But if you've got duplicates, get me message MI01. Well, which one of the 3? The answer is potluck. You don't know. The other thing is, and this has happened many times, when I'm getting messages, I need to set it to none before every get. Okay, or MQMO none, match options. And the reason is, you can kind of follow my little diagram. As I get the first message, and I have not reset the thing for the second get, it literally is going to start looking for a particular message in the queue. So with MI01 in my message ID, it would look at the next message, message 02 on the queue, find MI and say, oh, it's MI02, not the one you want. MI03, oh, not the one you want. Okay, and eventually maybe hit the end of queue, designated by the no message available reason code. Now, I have been on many assignments where somebody would say to me, the developers would say to me, yeah, MQ is pretty slow and only processes one message at a time. I introduced them to how to set the message ID to none. All of a sudden, messages can be found. One case, extreme case, there were 1,000 messages in the queue. It literally got the first message and then promptly went through 999 messages in the queue, ended, and went away. Start the task again, get to one more message, read through 998 messages before it went away. You get the idea, okay? So that is, the calls, if you will, a bit about the actual application interface. So let's kind of move on. So we're going to look at trace. So again, in CICS, every entry, right, ERM entry to ERM exit, there is a trace entry. So this is ERM entry is getting into the interface, ERM exit is getting out, okay? I do have short trace entries, so these are the times you can see at the top and the bottom. And I did the subtraction, 0.064 something seconds. Now, doesn't look like much, but in that little bit of time on my little system, we've gone through about 1 million instructions, okay? Between the interface, over the MQ, etc. Okay. The actual call in this case is an MQ open. So I've kind of highlighted it down here. We can see here's the true entry and true exit. Okay. I've actually used the ERM exit getting control back from MQ. And that time there is 0.062. So that is time actually we've been over in MQ itself. We can see it's an MQ open call. Here's the actual queue name. And of course, the completion code is 0, so it worked. Okay, so there is what one of the calls looks like in Trace. Moving on to the next slide. Okay, so the MQ get, similar thing. Entry, exit, 0.0035, not a lot of time, but about 250,000 instructions. It is an MQ get call. It did complete successfully, MQ0. And again, here's the, again, I've taken the ERM event coming back, but again, MQ true entry, MQ true exit. The two entries are almost back to back, as you can see in the times. But basically, that is the actual time over in the queue manager itself, okay, in the MQ region as it says. So we can see exactly where we are. And again, moving on a little bit. So I'm going to do a put one. So my little application, as I was describing it before we were kind of messed with the audio, is putting a request message with put one, turn around and waiting on a response. Okay, and the MQ get call gets the message response. Now it's going to put a reply, or put an actual message coming back. So the MQ put one call, and again, on the left-hand side of the diagram, right, the time spent in the interface, 0.005. On the right-hand side, the time spent in the actual MQ region itself, 0.0049, sorry, very close. So most of the time is actually within the region itself, MQ region. And again, this is a put one call, and you can see the queue name, results queue, and it is successful, MQCC zeros. Okay. So moving on a bit, the next call is the close, or MQ get call, to get the response coming back. Again, there's two applications running, two different transactions in CICS. Now, this is actually getting, now I want you to notice here, we do have an exception, okay? MQCC 2 rather. And then the MQRC, funny hex number, actually turns out to be the equivalent of a 2033. That would be the actual decimal number, 2033, which is no messages in the queue. That's that no message available. So we've processed all the messages in the queue. Okay, and again, you can see the timings. So, we've put a request, it's been processed, we come back and get the response, we try to get the next message. Typical application, we would get the next message on the queue, and we hit the end of queue, we're happy. So we go on to the close, okay, and again, here's the MQ close call. Not too exciting, okay, not much here, if you will. Pretty quick, 0.0058. It does have to, do some cleanup of memory and things, if you will. Okay, for the last little bit of trace, pretty complicated, but I want you to notice, this is my application doing a CICS return. The solid vertical or horizontal lines, I've left out a bunch of trace entries. And you can see on the right-hand side the sequence numbers of trace. You can see how many I've left out. Now, I'm obviously doing this in an isolated system. I'm the only thing going on, so the trace entries are pretty close to each other. But you'll notice I see this, right, RM0. This is where we're doing the entry to commit. This is actually where it's going over to tell MQ we're about ready to commit. Now, we do not use the MQ commit or MQ rollback in the CICS application, okay, or I should say MQ back call. We are required to do the CICS sync point or sync point rollback. Most applications do not do sync points, but it occurs when they do the return. So part of the return command is going to do the thing. Now, this is going to go over to the true. So here we can actually see it invoking the true, okay? Now, point number A is really the total time in the actual interface itself, okay? B, if you look at my little notes, is the time that it communicates with the resource manager, RRS, Resource Recovery Services. It is actually that part of ZOS that's coordinating the committing process between both CICS and MQ. Point number C is the actual time, right, to spent in the queue manager to prepare to commit. So it's doing a two-phase commit just like MQ now, or like DB2 rather. Please remember my messages were not done under sync point control, so there's really no coordination necessary. The MQ messages were not part of the unit of work. However, D would be the actual time to do, right, to perform the actual commit portion, okay? MQ is still going to commit, but it just doesn't necessarily have to do a coordinate, okay? If you did sync point, you might see, MQ GMO sync point, MQ PMO sync point, you might see a few more messages simply because, there's more work to go on. There are a bit more time, okay? All right. So now let's go to looking at CEDF, and I'm going to go through this fairly quickly. Got to make up a little bit for the lost time, if you will. Now, my little screen, I have a transaction. This is RT00 transaction where I make the request. It's pretty simple. I supply the top line of information, right? This is like a little inventory application. Now, when you look at CEDF, it's stopping before it executes the commands, well, in this case, the call. Now, I know this is a put one call. Unfortunately, there's no clear indication of that in CEDF, but what I do see is the OD, the MD, and the PMO. The sum of those three structures being used says it's a put one call. I got to open, MQOD, and then MQMD to work with messages, and PMOs to put message options. That is how I know it's a put one call. And that's the only way I know. Now these are actually done in hex, but these are the parameters, those big structures that were copied in. So you're seeing limited information here, right, out of those structures. Call is complete. Notice I don't have, per se, a completion call. Well, I do. The first 4 bytes here, argument 6 would be the completion code. The next, or the first 4 bytes of argument 7 would be the reason code. Display them in hex, you would find their values, like all zeros, if it's okay. Moving on, we then get to the open call. And I think I put 2 different slides of the put one because of the text that went with them. I know it's an open because the MQMD, or OD rather, tells me it's an open call. This is on page 22, I believe. Now, I know that because that's the only structure involved. And again, the argument 4 and 5 here would be completion code and reason code. Moving on, a second open. I don't know why I did that, but it's the same open call. But it's, oh, I know, this is the completion command. Never mind. Before and after, sorry. Mine's not working. And again, completion code, reason code here, not on the previous slide. About to execute command, now I'm in sync, 24, right? So this is about to execute the command. Now I know it's a get message because here's the MQMD and the MQGMO. That tells me it's the get. Don't know it's a get with wait unless I could find the options, right? But again, this is about ready to complete or execute. Second slide, right? It is complete. And again, here we would see the completion and reason code, okay? I know it's a get with wait because of the way I coded. There's nothing in these parameters unless I could see the full things that would tell me that, okay? Finally, I show you a close call starting on page 26, okay? And again, no parameters here. That's what tells me it's a close. There are no structures, no eye catchers involved. And of course, command execution complete on 27. And again, I know that arg3 and arg4 here would be completion code and reason code, the last two parameters. Finally, the last little bit, here's my screen now populated with information that came back from the other task. So my little application, RT00, presents a screen for me to enter in a particular code and quantity, etc. Puts one to a message, does a put one call to a queue, wakes up a transaction, actually triggers another CSS transaction called QT00, which processes the message, updates the file, produces the results, and shows me the information. Okay. Statistics. Quickly through these. So these are your shutdown or interval statistics, if you will, from CICS, from my 5.3 region. As you can tell, this is CICS 7.0. Essentially, it's up top, it's my name or my connection resource you'll see here in a minute, but it does tell me the queue manager. It does tell me the version, in this case, MQ version 8, okay? It gives me a bunch of statistics. Now, this is overall. You know, obviously, I was the only task. And it does tell me the number of calls I've done, right? I've done several iterations of the task, if you will, but you can see overall calls, okay? Now, this is pretty much all the normal or most used calls. The open, the close, the get, tells me how many are gets with wait, right? Put ones, inquire and set is calls to, pardon me, inquire attributes of a queue or set or change attributes of a queue, right? So pretty much, you know, just overall general statistics. Moving on, there's actually a continuation. There's more to it. I just can't fit it all on the PowerPoint slide. A bunch of calls were added. Well, up front we see in doubt units of work, unresolved units of work. Something went wrong in trying to clean up MQ units of work. Okay, don't know what. Very rarely do I see that. It does tell me that I did a total of 11 tasks, committed units of work. You know, if I did things where changes were required. Now those are the background tasks mostly that are doing the thing. The background task that's updating the file, I did gets and puts under sync point, so it is within a unit of work. It does tell me single phase versus two phase commits. And again, a bunch of new calls that were added in version 7 I'm not going to get into, right? Raw statistics on the number of calls being done through the interface. There are detailed records, right, that tell me per task the calls, but the actual statistics that come out at interval, whatever, just raw statistics on the whole interface, okay? Okay, a bit more technical. Let's get into the resources. So the interface, very similar to DB2. In fact, folks in Hersley admit that they stole the interface from DB2 and brought it over to Hersley, put it in CICS, which is where both MQ and CICS are developed in Hersley, England. So it is RMI, remote method or resource manager interface calls, API type calls. I do have TCBs that get set up. Now, unlike the DB2 interface, I don't tell it how many you're going to see. You'll see the definition coming up here in a moment. It is multi-threaded, so I can do multiple concurrent calls. There are two other tasks that get started with the interface. The CKTI is the trigger monitor. So I start with trigger monitor. That's how I can, you know, trigger applications in CICS. The trigger monitor is looking at something called an initiation queue. You will see in the next slide. And the queue manager will put a message into the queue, wake up the trigger monitor, it will start the transaction. That's how my little QT transaction gets going. As I put a message into my transaction queue or request, that is triggered, defined with a trigger in MQ, wakes up the trigger or wakes up MQ, gets the information, builds a trigger message, wakes up the CKTI to start QT00 in the background. Okay. CKAM is the alert monitor. There are cases where MQ will say, I'm shutting down, or I'm got an error on your queue, or I'm closing your queue, or whatever. And it kind of gives CICS information, about what's going on, if you will. Okay, pretty simple definition over on the next slide. Define MQCon. Within the parentheses is whatever I want to call it. Now I keep mine equal to the name of the queue manager. You'll notice the MQ name, that's the actual queue manager name as the subsystem is defined to ZOS. I keep them the same just for my own sanity. Only one queue manager may be connected to CICS at any given point in time. Could I disconnect and connect to a different one? Sure. I'll show you the commands at the very end of the session here. All I simply have besides this, the name of the queue manager, is the init queue name, right? The initiation queue that the trigger monitor uses. And by having that queue name there, it automatically starts the CKTI transaction. Pretty simple. Now, the MQ interface does use the Open API interface and consumes max open TCBs. But again, unlike the DB2 interface, I don't set a limit. In the DB2 interface, I set a TCB limit. Here, it can consume up to max open TCBs. The thought process is most of the MQ applications are fairly short-lived in MQ. They're not doing complex things like, cursor processing in DB2. It's let me do an open, let me do a put, let me do a get of messages, right? Pretty simple, pretty straightforward. So the assumption is you're not going to be tying up TCBs for a very long period of time. Okay? That's just the way it is, folks. There's no way to limit. If I had enough transactions doing MQ, I can consume all those TCBs. Queue local definition on 35. This is the init queue. Please notice I want it to be shared, but more importantly, I want FIFO. I do not want MQ working with priorities. I want the trigger monitor to be able to get the messages off the top of the queue, rapid fire, first in, first out basis. That's how the applications get triggered. Max depth is 1,000. The thing should never get more than 1 or 2 deep. On high volatile, highly active systems, I've seen it get to 10, 20, 30. 1,000 is more than enough. The max message by default is 4 meg. I have never seen a trigger message that big. In fact, they're less than 1,000 bytes total. I just arbitrarily said 4,000, right? Just for grins. If I member makes a trigger message that big, I don't know what they put into it. So that's the trigger queue that I need. Okay, 1 per CICS region, or I could have multiples. I can do multiple trigger monitors. Okay. On the next slide of the definitions is the actual queue definitions for my application. So I have what I refer to as my transaction queue. I do a max depth of 100. It is shared. Here's the trigger, and then this is the process that tells it what application to trigger. And this tells it which trigger queue to initialize, which basically tells it which CICS region to start in. I'm starting it in the same region my RT00 is running, but I could start it in a different region. I could fire off the transaction in a different CICS region by having a different named initiation queue. Okay. Here's my little results queue coming back, and again, this is the queue that accepts the reply coming back. My process definition, as you can see, and you can see here's my transaction that gets initiated. Okay. Pretty simple. That's how it all works, right? RT00 puts a message into the transact queue. MQ triggers off. That application does the update of a file, puts the results in. My application wakes up from the get with wait and processes the results. And you saw the screen. Okay. Quick look at the dump. So looking at a system dump, if you will, this is the summary, okay, that comes out of the normal IPCS tool, looking for the MQ summaries. Again, kind of a repeat, what queue manager am I connected to? What's the version? What's my initiation queue? When was it connected? right? When did it physically get, that could be days, right, in the past. Two little summaries, and I don't know why IBM shows two, to be honest, but it's the trigger monitor summary, and I only have one. I can have multiples, okay? But my task summary, right, and then when the statistics here, when I did this, took the dump, if you will, I had no tasks that were actively using MQ. But basically, you can see the trigger monitor. It does tell me the task number. It does tell me this life of task block, okay? Lot address, if you will. And I'm going to show you a bit more about that. And of course, this out here in the tail end tells me if it's inside of MQ or not, okay? So that's pretty much what you see in the summary. Now, the crazy part, the actual data areas, none of which are documented. The last time these data areas was documented was the last supplementary data areas manual, which was CICS TS 4.1. However, many of the things are still true if you happen to have that old manual, okay? We have what's referred to as the MQ initiation block, and essentially this is just telling me things like the initiation queue name, queue manager name. This is the block that controls the information for the connection, if you will. The life of adapter block is next, and again, key information about there. I give you a few little displacements in there, if you will, that still kind of exist. Life of task block is kind of documented. Again, it was documented supplementary data areas. Pretty much everything is still true to form. This is similar to the DB2 life of task block, which is actually documented, okay? And again, you can see the lot. It does have the transaction. This is the user ID. The thread block that's being used. And again, here's the queue name for my application. Some basic things, right? And it does tell me, the information. They do pick out the key things here. It's represented a get with wait. Trigger monitor is doing a get with wait on queue. It does tell me the application queue name, right? So key things are pointed out. Not much in the actual data areas, folks, I really care about, right? In a very highly active system, the summary gives me everything I need to know about the applications using MQ. Getting close to being done. I'm going to go over by a couple minutes, but sorry about the loss of audio, but we got back in sync. Unfortunately, I see about half the people dropped off. Hopefully they'll get the recording later on. Okay, so for the last few slides, I want to go through this CKQC transaction. Provided by the interface, allows me to control the interface itself. So if I key CKQC from a cleared transaction or cleared screen, I get the first screen. 3 different menu selections. Okay, so I put my cursor on connection and hit enter. I get the drop down you see next. This allows me to start or stop the interface, change something about it, but I'm saying let me display the interface. So I notice I took option 4, and you get what you see on the next slide. A basic summary of what the interface, of what's going on. Now, we can see all the information at the top about the queue manager name, the Apple ID for CICS, etc. It's connected, and so on. Number of in-flight tasks is 1. Running CKTIs is 1. Total number of API calls 4393 between my applications and CKTI. And then we see the breakdown of the calls, pretty much like you saw on the statistics pages, right? How many were run okay? Futile. How many calls basically went awry or went astray, if you will, could not be completed for whatever reason, typically because the queue manager is not connected, or CSS is not connected to the queue manager, basically. Opens, closes, gets its wait, puts, and so on. You can see. 2-phase commits, right? 2-phase versus single phase. Again, because I'm doing no sync points, when I was doing all the transaction, GMO, no sync point, PMO, no sync point, there's single phase commits. No real coordination necessary. Again, your application's choice, right? So the next screen, I've gone back to the previous menu. I said, let me do option 3 to modify. Well, the modify pop-up is shown on the same slide, okay? And basically, it only allows me to reset statistics, enable or disable the API crossing exit, which I don't do. You're allowed to write your own little exit to, get control as the interface, the about to execute, command complete type scenario. So you can actually do things yourself. I have seen a few people do their own counts by applications. That's about it. Not necessarily in a lot of cases. Option 2 on the next slide, let me stop the interface. And again, the secondary pop-up in the middle. Quiesce means allow all applications to complete before you terminate the interface. Force means kill them, shut it down. Option 1 to start the interface again, and again, pretty much the MQCon parameters. But if I stop the interface for MQAA, I can start to a different queue manager. So if I want to stop to one queue manager, start to a different one, all you need is do is stop and then put a different name in here. And I can start the connection to a different queue manager, one at a time. Highlighted the CKTI on the main menu and hit enter, got the pop-down menu here. And very simply, I can start, stop a CKTI transaction, or I can display the interface. Display is pretty much what you saw in the summary dump. Task number 31, normal, it's going to get with weight against that queue, and it's done 9 API calls. Nice information, but not a lot. Now, I can, however, do option 2, stop it, right? The way you stop it is you supply the name of the initiation queue, okay? You could have multiple CKTI transactions running. So the way and typically you're supposed to have your own unique initiation queue for each CKTI. So I supply the name of the initiation queue. That tells the interface which one to stop. And if I go to the next slide, to start, option 1, you can see I supply the name of the queue. So if I had 2 different initiation queues in the same defined for the same CSS region, I can have 2 different CKTIs running. I have seen people do that. There's no limit to how many I can get running. I just really need to have unique initiation queues. Okay? I know somebody asked a question. I did not catch it because I got sidetracked by my sound going nuts. Bear with me a second. Are there interfaces to get multiple items? Okay. One message at a time. So you get one message at a time. There's no way to do multiples. There's a way to not get intervening responses coming back. Asynchronous reads, asynchronous puts, or gets and puts. And you can get status of all of them at once, but you still have to do one message per put or get call. Okay? I know what you're thinking of. Multiple row fetches in DB2. Okay, anyway, so back on track here. Almost done. So basically, I can add more CKTI transactions, right? And different initiation queues. Okay? And you saw how in the queue definitions how I relate an application. So kind of as the last slide, I put the cursor on the task option on the main menu bar, and hit enter, and I get all the task lists. So again, this is like the task summary in the dump, if you will. And it would show me all the transactions. Again, I had almost none, right, in use, if you will. The CKTI transaction, bear with me here. You know, the CKTI, again, transaction number, it is in a wait state, right? MQ get with wait. Thread ID is just if I wanted to cancel the thread from an MQ perspective. Typically, you simply cancel it from the CICS perspective. And all I have to do is cancel, use this EMT transaction. You'll see these things running plus your tasks that use MQ. You simply cancel it from that point of view. Okay. So I kind of made up for lost time. Maybe I went a little too quick. Sorry about the audio, folks. I have no idea what happened. It got back. You do have my email. If I can help out down the road, answer questions, by all means, send me emails. I do answer them. I thank you for attending, and I hope I have given you some useful information about the interface from both a application and or system point of view. Have a good lunch or what's left of it. I will see you maybe sometime in the future.